Our instructions say to give the center and radius of each circle. Well, these equations are given to us in general form, and that's not very helpful for identifying the center and the radius of the circle. We want to transform these into standard form, which we see here in the box. To do that, we will use completing the square. So the first thing that we want to do is we want to group our x terms together, group our y terms together, and then move our constant to the other side. So we have x squared plus 10x. Notice I'm going to leave a little space. We have y squared minus 6y. And then we'll subtract 25 on both sides, so that will be minus 25. Next, we will complete the square for the x's and for the y's. For the x's, we say half of 10 is 5. 5 squared is 25. So if we add 25 on the left, we need to be sure that we add 25 on the right. For the y terms, half of, it is negative 6, but we're going to square it, so it's going to come out positive anyway. I would just think of it as 6. Half of 6 is 3. 3 squared is 9. So we'll add 9 to the left, also adding 9 to the right. The next thing we will do is we will factor our perfect square trinomials. So x squared plus 10x plus 25 factors into x plus 5, quantity squared. Y squared minus 6y plus 9 factors into y minus 3, quantity squared. And then this is equal to negative 25 plus 25 plus 9 is 9. Now, we are much more readily able to look at the equation and identify the center and the radius. The center of this circle is negative 5, 3, and the radius is the square root of 9, which is 3. All right. Now, we have another one that we're going to look at, but it's important to remember that the lead coefficient has to be 1. So we've got a couple of different ways that we can deal with this. With the circles, it's almost easier to just divide the entire equation by whatever the coefficient of it is. And the coefficient of x squared and y squared will actually always be the same on a circle. So now we have x squared plus y squared minus 4x plus 2y plus 2/3 is equal to 0. Now we'll pick it up right where we started a while ago. We'll group our x's, we'll group our y terms, and we'll move our 2/3 to the other side where it will be negative 2/3. All right, completing the square on the x terms, half of 4 is 2, 2 squared is 4, so we will add 4, and we will add 4 here. Half of 2 is 1, 1 squared is 1, so we will add 1 and add 1. When we factor, we have x minus 2, quantity squared, plus y plus 1, quantity squared, is equal to negative 2/3 plus 5 is 4 1/3, which is 13/3. So our center is located at 2, negative 1, and our radius is the square root of 13/3. And if we rationalize that, we get square root of 39 over 3. And if we were going to graph that, we would certainly want a decimal approximation to be able to help out. One more example, we do already have lead coefficients, or the coefficients of our square terms are 1 in each case, so that's good. But when it's time to group, if you'll notice, we only have y terms that need grouping, not x's. So we will have x squared plus y squared plus 5y, and then we will move our negative 2 over to the right-hand side. So when we complete the square for the y's only, we'll take half of 5, which is 5 halves, and we will square that, which is 25 fourths. So we will add 25 fourths to both sides. Okay. We will factor. Now we don't need to factor the x's because it's just the x squared term. We do have the y's to factor. It is y plus the square root of 25 fourths is 5 halves, quantity squared. And negative 2 plus 25 fourths, that's going to be negative 8 plus 25 is 17 fourths. So for the center, it may seem a little strange because there's no h with our x, but what's the only h that could be added or subtracted to x and not be written? It's 0. So we have a center at 0, negative 5 halves, and a radius of the square root of 17 over 4. Sorry, my square root wasn't big enough, so I'm going to just put a separate one down there, which is the square root of 17 over 2. I'm going to stop the video and do some additional examples. I recommend that you try them first and then check it based on the notes. So take a minute and please check to make sure that you got the correct center and radius for each of the circles. And that's how we can take an equation given to us in general form and convert it to standard form.